Good evening and welcome to another Alternator movie. This is a Mitsubishi core alternator, but this is a Mazda version. This is the alternator that my wife has on our Mazda 5 family car. My voice is a bit terrible compared to the other movies because I just had a week full of fever, cold and that sort of stuff. And I don't really have my voice back yet, but let's hope I can still make a good movie out of this. So, as I said, this is a Mitsubishi core. This is a weird alternator, reliable alternator, cheap alternator to rebuild. And pretty easy alternator to rebuild, but it's a bit different from what you're used to. Now normally with the typical Bosch or Denso type alternator, we remove the nut, we take off the pulley, we separate the housing, or we take the back plate off and we then separate the housing, and then we end up with like a driven end housing with a rotor in our hands, which we can then easily press out, and we end up with a non-driven end housing with the rectifier still on and with the winding somehow connected, and we'll just repair it. In this case, this won't work. If I will take off the pulley, pull off the pulley, take out the bolts, separate the housing, I will pull the housing through the shaft of the rotor, which is not a problem, don't worry, but I will not be able to get the rotor out. So you would end up with the non-driven end housing, with the winding, the stator, and with the rotor in, and you wouldn't get the rotor out. And that's because of the non-driven end bearing that kind of sets itself in place with rings on it. So what you do, very simple, you remove these 4 bolts. You use either this ear or that ear over there with a hammer. You tap with a hammer until you get the entire driven end and rotor out all in one piece. You put that away and dismantle that. You dismantle the non-driven end housing and you've got the alternator dismantled. So, let's get to it. I'm going to get rid of these 4 bolts and just cut the movie. Then we'll hammer it out. Be right back. Okay, bolts have been removed. I'm taking a dead piece of metal just to make sure that I don't hammer into the soft metal here, which I will then bend. And now I just want to tap with the hammer and get that driven end housing and the shaft, the rotor shaft out at once. There we go. Now it's coming loose. Alright, so here you see the driven end housing with the rotor, with the slip ring, with the bearing. Look at that slip ring, that's like almost new. Alright, gonna put that away from now. I can take my earphones off because we don't need to use that hammer anymore now. Okay, so got that driven end housing with my rotor here, and I've got my stator with non-driven end housing. Let's quickly do that driven end housing. This is not special. I'm going to remove this nut here. I'm going to take the pulley off. I'm going to push the rotor out. I'm going to take the bearing backing plate out. And I could take the bearing out, but I'm going to leave it in because I want to pearl blast the housing. Rotor itself is also nothing special. This is actually a pretty nice design with a nice fan. The slip ring here is soldered properly. And it has a lot of, let me see if you guys can see this. It has a lot of wire material. So if you accidentally cut the wire, you have a lot of material left to make a good soldering connection. So this is actually a very amateur-friendly alternator. As I said before, the slip ring is actually still thick. If this alternator has almost 200,000 on it, but if you would tell me that it has 50,000 on it, looking at the slip ring, I would actually believe you. The bearing, however, is shot because I just spun the bearing. Well, I wouldn't say shot, but that's dry. So this bearing needs to be renewed. So it's actually a good thing I'm rebuilding this alternator. Now that non-driven end housing with that regulator and rectifier. Yeah, this is something special. So non-driven end housing with the stator core in it. Especially if you guys have some experience with alternators, you don't see anything special here. Well, okay, we see a fly here that got caught on my stator and that burned. All right, whatever. Now check this out. We've got the 4 leads over here, so that means we already know that we're talking about a what is it, star stator. And now you see that those leads are clamped and then soldered to a rectifier, which so far is also normal. That rectifier is then connected with this voltage regulator that also has the brushes. So far still normal. But how am I going to solder this and clamp this? Because we are used to having the stator leads going out from the housing about here and putting the rectifier on the housing and then clamping and soldering. But what I did here is, first you bolt down the rectifier, then you do the regulator, then you solder rectifier and regulator together, then you put in the stator, and you bend and mold it the way it sits nicely, you clamp it, then you drop the solder in right here. That's how they did it. So, not really a problem, because now we just have to like hack away right here and get this out and be careful that we don't damage the lamination. But less friendly than the original or traditional design where they stick out on the back. So I'm gonna put some heat over here. I'm gonna use pliers and cutters and cut away at those clamps, because I want to get that stator core out ASAP, so I can just unbolt the regulator and rectifier and just toss them away. Right, so to continue I take, let's see, a 24. There we go. There we go. Now watch this. Super loose bearing fit. Check this out. There you go. Super loose bearing fit. So that's the problem with not being able to get everything out the traditional way. I'm gonna keep that ring. Let's not forget that we have a ring over there, but we gotta put that ring away. Let's see. I had the tension from this already. Bearing backing plate 4, 1, 2, 3, 4. Never mind, that's number 4. Hang on, don't need my earphones anymore. Alright, let's see. Driven and bearing, still okay, but we're not going to reuse that, of course. This is an NSK bearing, so that's premium stuff that they use in the factory. That housing is ready for the Pearl Blaster, so we don't need to put any more time in this. Okay, I'm gonna check how I've got the camera set up, because I really want you guys to see me taking this apart, because this is such a special, this is such a unique unit compared to the regular alternators. Okay, I also got my soldering iron here in case my cutting tactic won't work. And I wanted to do it in front of the camera, but I need the table. So I'm just gonna cut away at those guys. And now I want to take pliers, because I don't want to put cutting tool on the copper material. Accidentally cutting the lead would be a little disaster and screw up my stator. There we go. Okay, let me show you. Without using the soldering iron, I just cut away at the clamps until I saw that the wire was coming free, and then I just took pliers without a cutting edge and wiggled with the wire until it broke free. And the wire is still dirty with clamp material, but we'll get that off once we have the stator out, because we can then just approach from the other side with a die grinder. So I'm gonna cut and work on these other ones, get them out, maybe use the soldering iron, and I'll be back with you guys. Okay, and I've got the last one out in one piece, so now I just want to use a screwdriver and wiggle out the entire stator. There we go. And now with the wires out, I can just put them back in position. And you can see the way the wires are originally. And you can also see that I accidentally cut the tips off this one. This is a phase, this is not a start point, but I'm gonna just have to put them back in position. And as you can see, by making the turn a bit different right here, I can still get it as far as the other ones, so I can resolder it. Okay, so we've got a damaged rectifier with damaged points that we can no way reuse. Regulator that was okay with pretty much quite some brush material left, but we want to rebuild this guy totally. Gonna take these ones out, gonna take that guy out, and that's when we dismantle the entire non-driven end part. 1, 2, breaking that regulator, 3, old brittle plastics. There's a little cap over here, I believe. Yes, and that cap allows me to take off that point. Okay, I should be able to get that regulator and rectifier out now in one piece actually, or together. Probably gonna break because it's old brittle plastic, but normally they would now come out. There you see, that's the brittle plastic of my rectifier, screw that. What about my regulator? They're a bit stuck. See if I can help them a little hand. There we go. So this is coming out. So there we go. Drops right out. I mean, unusable, but basically you get it out like that. Let me get all the debris. Gonna throw that away. Okay, so the non-driven in housing is now empty. I'm gonna use nut bolts so I don't screw up my bolt holes. I'm gonna put some duct tape or some plastic in here so I don't screw up the bearing seat with my pill blaster, but this is ready to pill blast. Okay, end of the first part of this movie is gonna be finishing that rotor, and this is day 2 for me because I had some business to attend to, so my voice improved a bit. I'm gonna need to get rid of that bearing, and this is a nasty bearing to get rid of, and then I'm gonna need to get rid of that slip ring. Luckily this is easy and they give you a lot of wire material. I don't have the right puller to pull off this bearing, I have to destroy it, so the first thing I'm gonna do is pry at the seal. I need to get that seal out, so I just take an old sharp flathead screwdriver. Let me see what we're looking at. Okay, now I'm looking in the bearing. There's still some grease left, but it was very noisy, so that's definitely not enough. Now I want to destroy the cage that holds the rollers. I think I've got that coming out now. Can't see because of the grease. Yes, that's definitely the cage. There we go. Plastic cage. Now I want to get those rollers out because I want to pull that bearing off. See, now we're getting some play on the bearing, so I can actually get those rollers out. Attempting to show you guys as much as I can without my hands being in the way. The moment we've got a roller out, the rest will come. Oh, there we go. Here's the rollers. Rollers coming out, just a few left. There we go. So now we should be able to take that outer ring off, and we just did. I think I'm gonna have to put this in the vise, and then I'll need to drive something through here to get distance on it, so I can get something in between. Yeah, that's how we're gonna approach this. I'm gonna put a dummy bearing on. Here's an alternator bearing that I'll put on. There we go. You see right here that I'm getting distance, so the race is coming off. Just need to tap a bit more. Now you also see why I always keep my old alternator bearings, because they make excellent dummies, so that I'm not putting any tension on the shaft. There we go. Okay, so I've got the outer and inner race safe. Shaft is okay, got it off. Little bit of a nick here, but that doesn't matter. I'm gonna desolder the slip ring right now, and I'll zoom in. And as I desolder, I'm gonna use the pliers or maybe a screwdriver to get the wire out safely. I guess I'll need to use a screwdriver because I don't have room for those pliers. So let me give you guys a little bit of zoom. Here we go. I'm gonna shove this right over there. I'm heating up my soldering iron. I'm gonna get my mask. There we go. Now we can go ahead and destroy that slip ring, because I'm not going to get anything under it. So alright, here you see my shaft without slip ring. I just used a big flat screwdriver. I hacked away at it, got it out. Here you see the remains of my slip ring. Not much. I'm going to sand this a little, then I'm going to put some bearing grease on it lightly, then I'm going to push the new slip ring on, and I'll do that right here by hammering it. Let me get the new slip ring out. Got the new slip ring right here. Let's see if it fits. That's going to fit, see, because it fits over the shaft. Just have to push it in place, no problem there. And it's gonna have to be fitted this way so that I can put those wires through those ears. I've got my acid and my lead right here. We're gonna need that. Okay, let's see. Just about like this, because that would allow me to put that wire on. Maybe a bit more like this. Nah. Yeah, this is about how it should be. Okay, now I need my headphones. Well, what do you know? I actually forgot to put the bearing grease on that I was so happy about. Hang on. Alright, got the bearing grease on. Reason why I used my finger to put some bearing grease on the base is that when I took the slip ring off, I could see that the base was a bit crusty. So I sanded the base, and I want to make sure that the next guy doesn't get a crusty base sticking to the slip ring. Yes, my socket will handle this. That should be it. Let's give it one more tap. Yeah, that sounds good. Now for the next part I use these pliers to route the wires a little bit, so I get a similar connection to what we had. Although I'm just being Mr. Perfect right here, sorry. So we're going to put those wires right in those ears, that's okay. Now we're going to put that wire around. Okay, see, there we go. And now we want the wire to go over, down on the ear like we saw when we were dismantling this slip ring. And all we got to do now is drop the solder right on. So it's a little bit of more work compared to those Bosch units where you have those ears and you just have two leads sticking out, but this is kind of better because now you're dropping solder, so gravity is now working in your favor when you're doing the soldering. And on those Bosch alternators, gravity is not necessarily your best friend. There you go. Clearance from the shaft so we don't get any ground issues. Let me see, let me just move the wire a little bit away from the shaft. See, that way, no way we're going to get grounding. No way. We're going to drop the solder right on. Let's see what we have here. Same here, let me move it away a little bit. Okay, wire good. This is going to be fine. Okay. Final part. Let's get that bearing on. Don't need that anymore. Okay, just a bit more. That's too bad. We'll just have to take a socket. Okay, bearing sits. Welcome to part 3 of the movie. I got those houses painted, driven end and non-driven end housing. I'm gonna need to replace that bearing now. Remember, I left the bearing in so I could spray paint around it without damaging or painting the bearing bore. See how easy this bearing comes out. It's coming out, so no issues over there. Here's our driven end bearing. Definitely. Yeah, backing plate will fit nicely. No specific way to put the backing plate on, so that's okay. Gonna need those 4 screws. Right, and now that this one holds, we can put in the rest. We can tension this later. I just want the backing plate to be in position right now, and we got that in position. Not gonna need them anymore. Okay, so that's the driven and housing pretty much ready. Let me put that aside. Alright, now remember in the beginning of the movie I was talking about how I think this is a weird alternator. This is actually the part where we're gonna look at the weirdness of the alternator. So, first let me put that rotor aside and let me use that big bearing as a support for this housing. Basically we've got a rectifier that we need to put in and a regulator, and after we've put those in, that's actually the moment when we can solder everything down. So I now first want to take the regulator, and you see that the regulator has like a little rod in here, and you need to keep that rod intact, because the moment you push out the rod, the brushes are going to shoot out. So we need that rod. It also has this plastic piece that we can just get rid of right away, because we're not going to need that now. And now we want to put the rectifier in with the rod in the little hole right here, and that rod is going to stick out, and that's how it's supposed to be. So you see me dropping in the rectifier like that. There you go. And what I want to see now is that the rod is nicely out on the other side. Don't know if you can see it, but right here we have the rod. Right, and now we want to put the rectifier itself in. So we want to cut that little speed wrap over there. And we should have actually done that rectifier first. Hang on, let me just take out the regulator. Okay, gonna drop that rectifier first, my bad. Gonna put that regulator with the rod on top of it. There you go. And now you'll see that the regulator and the rectifier are connected right here. This one sits, this one goes over, and we're gonna solder this down. I guess you could push the clamps down. I don't. I'm just gonna solder them and make a connection like that. So now we actually had bolts for this, so we're gonna keep them in place. And this is gonna be the definite position of these parts. Okay. I may have scratched the plastic a little bit, but feels nice and solid. No, not going to be an issue. Alright. And now that we've got this guy in position, right there, we can actually test the way my winding is going to sit. And I just want to see, oh look, I actually straightened those lines so I could clean them. And you see they're not going to fit because I need to bend them more. So what you're going to do now is check if it's going to fit. No, it's not. Then you're going to modify the way they curve and run. And you're just going to check again until you've until you have them fitting in the slot where they're supposed to be on that rectifier. So I'm gonna try. So after some playing with pliers, whatever, hang on, let me get a screwdriver. You see that this guy now fits in the clamp, this guy, those guys, and those guys are now fitting in the clamp. So what I'm gonna do is take the stator out, sand them again, because I may have actually introduced some dirt with my pliers. Then I'm going to put them down like this, measure connectivity, then I'm gonna clamp them, then I'm gonna solder them down. Okay, and I've got them seated, so now I'm going to use the pliers and clamp them a bit. So those little clamps on the rectifier will do the first job in holding these guys together. And the solder that I'm going to drop on is just a little extra. But I want this rectifier basically to do this alone. Okay, let me show you. I now have the leads clamped in those clamps and clean, so the clamps are now already holding everything in place. Theoretically the alternator would work now, but you want this to be protected from expansion or shrink from temperature and whatever it's exposed to, so you want to drop some solder on it to seal it, and then you want to solder these guys too. Before we continue, we want to make sure that the entire pack, the entire lamination pack here, sits nicely in the housing, because this is the only chance we have. After the soldering, we preferably do not want to touch the stator anymore, because we could risk destroying one of our connections. Now I'm going to put the housing back on this old bearing. I'm going to put some accessories away. Don't need this old stuff anymore. I changed the camera position a bit so you really see the soldering action. Okay, we have 4 leads soldered. We're going to continue with the regulator. Alright, we now see 1, 2, 3, 4 leads done, and we see that we have the rectifier and the regulator soldered together too. I got a bit, I overdid it a little bit here and here, but these pins are now definitely connected to the other pins. They already made contact by putting them on each other, and now the solder basically sealed it. And we've got a nice good solder on all of these, even the ones that are cut, they are properly in position. I cannot release the brushes yet because I need to put the rotor in. So here we got the rotor. New bearing, slip ring new. We already checked out that slip ring, so I can just fit the rotor. I'm going to put lightly oil the outside of the bearing because I don't want moisture or whatever to be able to rust on that bearing. Okay, and this should drop right in. Let's make sure we really completed everything. Yes, I've got this guy on. Driven and housing can go right through, so there's no problem over there. Yeah, so I should be able to drop this right in. Let's go. Alright, rotor is in. I already lubricated the shaft with motor oil. You see it's a bit greasy. I always lubricate those shafts with motor oil to make sure that moisture and whatnot is not going to get at the shaft and actually eat away at it. And before we continue, let me get that spacer ring and clean it a little bit, because we had like a spacer over here, and that allowed us sufficient clearance to fit this driven end housing. Let me see, yeah, driven end housing is ready to assemble. It should go right over because it's a pretty loose fit, just to help it out. There we go. You saw that happening, didn't you? And now we need to turn it into the right position, which was, let me see, this was the right position. There we go. Now it sits on the stator. and my rotor spins, so that's good. It basically already sits on the stator, so all I gotta do is put the screws in. There we go. And my rotor spins, so that's good. I'm gonna lubricate the inside of the pulley with some copper grease. Okay, final part is gonna be that little cap. Here's the. We already got this guy in, so let me get that cap on. Now let me put that rag away. See if we spin. We're spinning. I'm not hearing any fan contact or whatever. Nice spin. Last but not least, we're gonna take out those the brush container, and now you want to hear 2 clicks. So let's see. That's 1. I didn't even hear the second one. All right, now let's see what we're hearing. Ah, the sound. I'm not sure if you guys can hear it, but the sound changed a bit, probably because we're running in brushes now. Mazda Mitsubishi Alternator, right there. Hope you guys enjoyed the movie. Hope you learned from it. Check my channel for other alternator movies, car part movies, gearbox movies, whatnot. If you have a certain request for something, let me know. And I'll see you guys in the next project. Thanks for watching.